Good morning, everyone, and welcome to the crash course of JEE Mains. So, as you know, we have started with the crash course right from today, and there's a change of dates of JEE Mains. So, we are getting time after time, but yes, you might have prepared till now many things. Maybe something is left out, or maybe you have to work on some topics, right? So this is a very good time to work on that. Now, what we can do is we need to manage our time. We have around 1 month or maybe 40 days left for JEE Mains. So we can just plan our work, plan our timing. Whatever time we have, need to use it efficiently. And the most important thing is that you need to do varieties of problems. You might have gone through the theory part, yes, that is there always, but you have to do different types of problems. So when you say about maths particularly, so maths is a very, very important topic you have, a subject you have rather in JEE Mains, which plays a very important role. Right, so we need to understand the marks scored in maths is going to decide your rank too. So students, first of all, let us understand how the things are going here. Yes, of course, the classes, you can see me live on YouTube. Also, we have a Telegram app which is there, and we'll be utilizing that app to message to you have to ask your doubts on that group, and whatever doubts you have, you can post there. I can see, all teachers can see, right, and those doubts can be cleared, right. So we have a series of all the topics which are given in IIT Mains. So I just want you to adopt a strategy. Whenever we start a topic, you come prepared with that topic. Just read the basics of that topic, right, whatever the study material you have, then you can come to the class, and that will be really nice if you can come, because then the discussion will be a healthier one, right. Okay, so that is one thing. Secondly, we'll have those tests, weekly test. Yes, once all the chapters are finished, we'll have the test on a particular day scheduled for that. Right, so we'll have tests, then we'll have test discussion also. So those tests are also very important, because you have to be very, very attentive, and you have to attend those tests also. You can't miss those tests, because if you miss those, then it will be your loss, right. So as I told you, we have to be very pointed, we have to be very focused on the concepts. So similarly, from my point of view, from my teaching, right, I'll always give you the the important part of the topics, whatever the chapters we have, right, to make sure that you score or you make it right, right, whatever the questions asked in the exam, you do it right. So that is what we are going to do. So first of all, let's start with the topic quadratic equation. This is a very, very important topic we have, students, right, and let's start with this. So I can see here I have the group here. So if students can just write yes, if all the students have joined, we have Sanjay, we have Disha, right, Yuva, is it? Yes, just mark your attendance once, then we can just start the class. Come on. Everyone. Yes, come on. Chalo. Great. Okay, so we'll start with the class now. We'll take quadratic equation. Quadratic equation is a very important topic, and almost one question from quadratic equation is asked in last 10 years. And also, if you see the January session of JEE Mains, every session, all the sessions we had, all the exams we had, online exams we had, always there is a question from quadratic equation. So we have to be very specific. This is a very, very important thing. So what we are going to discuss in this topic, that is a very important thing. So we'll be talking about the definition of quadratic equation. Yes, this is a very important thing. You have to understand that definition. Secondly, we'll talk about identity, right? Then we'll talk about the roots, okay, roots of the quadratic equation, their nature, okay. Then we'll talk about common roots, the very common question asked in this particular topic, that is common roots, based on common roots. Then we have the sign of quadratic polynomial, right? Then we have location of roots or position of roots, right? This is what we are going to discuss. Got it? Then we can have some miscellaneous concepts one by one that come across in our topic, right? Now let's talk about the definition part. So first of all, if I talk about ax square plus bx plus c is equal to 0, okay, this is what we have. So when you say it's a quadratic equation, that means a is not equal to 0, right? This is a very important thing, isn't it? And also we'll be talking about all those real coefficient things. So our course will be dealing with only the real coefficients, a, b, c, not the complex coefficients, okay? So a, b, c are always real. This is always real, right? This is a very important thing. Now if you see here, a is equal to 0, then it becomes bx plus c. So this becomes a linear form, right? This is a linear equation. Linear equation we have. So this is a very important thing. A is not equal to 0. This is very, very important for us, right? Okay. Now, if I talk about one more thing, so this is how we define a quadratic equation, right? When you talk about identity, my dear students, so identity is a very important thing. When you talk about identity, identity is somewhat, if this equation is given to us, ax square plus bx plus c is equal to 0, identity have, this equation is an identity if it has more than two roots. It has more than two roots, right? So that means we are talking about more than two roots, more than two solutions. So it can have infinite roots, more than two roots. So this is only possible when we have a is equal to 0, we have b is equal to 0, and we have c is equal to 0. Because a, b, c, right? If I talk about a is 0, b is 0, c is 0. That means, students, what we have, suppose we have been given 0 into x square, 0 into x plus 0 is equal to 0. So whatever x values we substitute, suppose we substitute x is equal to 1. So 0 into 1 square plus 0 into 1 plus 0 is equal to 0. If we take 2, x is equal to 2, then also it becomes 0. If you take x is equal to 3, then also it is equal to 0. If you take x is equal to 4, then also it is equal to 0, right? So that means whenever an equation is given to you, so this is an identity, my dear student. This is an identity if it has more than two roots, and that is only possible when a is equal to b is equal to 0 and c is equal to 0, right? Hopefully this is clear to you. Come on, let me know if it is okay, everyone. Yes, if it is okay, just have a look at this. Fine? Yes, Pratik, Yuva, Sanjay, is this fine, beta? Disha, Chetna, is the concept clear, everyone? You could write something, type something on the, if the concepts are okay, everyone. The identity part is okay. Yes, so we need to use this chat box, that is a very important thing. So every time, whenever we'll be discussing something, I may ask you whether the things are clear or not. So you have to give yes or no, right? That is a very important thing. If you don't reply, then things will be, then the, you know, the communication will be not as smooth as it should be, right? Okay, fine. So we can see here, we have been given this two equation part. I have converted into an identity, and this is the way. Now, if I talk about identity, if we have been given, sometimes it may happen that find, right, find, suppose this question is asked, say you have been given a square minus 1, right, x square plus, got it? We have been given a minus 1 into x plus a square minus 3a plus 2, right? This is what is given to us, is equal to 0. And this is an identity, and we have to find the value of a. We have to find the value of a. If this is an identity, right? This is an identity, right, students? And we have to find the value of a. So what to do? So for identity, the coefficient should be always equal, isn't it? Has to be equal. Equal in the sense it should be equal to 0, correct? So that means we have what? We have a square minus 1 is equal to 0. So we have a is equal to plus minus 1. This is 1 point. Then we have a minus 1 is equal to 0. This is a is equal to 1, right? This is a square minus 3a plus 2 is equal to 0. Got it? And this is coming out to be a minus 1, and this is a minus 2 is equal to 0, where a is equal to 1 and 2. So you can see here we have the common part as, right? What is the common part we have? We have the common part to be what? 1, right? This is the common part we have. So we can say that the answer is coming out to be a is equal to 1, right? This is what we have, right? So sometimes they may ask you some questions like that. It may come maybe in JEE Mains or maybe in other competitive exams too. Got it? I hope this is okay, everyone. Right? So once you got it, let me go to the next part. Right. Fine. Now, if I talk about the next one, this is the most important thing, that is called roots of the quadratic equation. This is a very important thing, right? Roots of quadratic equation. Got it? Roots of quadratic equations, isn't it? This is what we have. So lot many problems are asked based on this roots concept, right? So we'll do few good problems today. Don't worry, we'll do many problems today. So ax square plus bx plus c is equal to 0 is given to us. Fine. So the roots are generally alpha and beta. Correct. And I have x is equal to minus b plus minus under root of b square minus 4ac divided by twice a, right? This is what we have. Got it? Now alpha and beta, yes, these are the roots. These are the two different roots we have, right? So always remember the alpha plus beta is always equal to minus b by a. This is a very important thing, isn't it? Then we have alpha into beta, product is equal to c by a. Got it? This is what we know. Now there are few cases, students. It's very, very important for us. Suppose we have been given b square, that is d, discriminant is b square minus 4ac, right, is always, if it is equal to 0, then we have two repeated roots, isn't it? Minus b by 2a. Got it? This is what we have. Fine. Similarly, if I talk about d is equal to 0, that is real and equal, right? This is what we have. Correct? Fine, students. Then we have d, which is greater than 0. So d greater than 0 means we are talking about these roots. d greater than 0. So we have what? We have real and unequal, right? This is what we talk about, isn't it? So that is a very interesting thing which comes now. See, so here what happens? B square minus 4ac, it may be a perfect square. Perfect square, right? Or b square minus 4ac is not a perfect square, students. Is not a perfect square, right? This is not a perfect square. So if it is not a perfect square, and if it is a perfect square, what is the difference? Then the roots are rational. So when you talk about perfect square means we are talking about, say, root 9, we are talking about root 4, we are talking about root 5, something like root 25, right? This is what we have. Suppose we have been given, it is not a perfect square, say root 5, say root 7, say root 3, right? So here the roots are irrational. What we call it as irrational roots, right? This is what we have. Got it? These are irrational. If it is a perfect square, it's fine, roots are rational. If it is not a perfect square, then roots are irrational. Irrational roots always occurs in pairs. If one root is, say, a plus root b, the other will be automatically a minus root b. Fine. This is what we have. If a plus root b is one root, then a beta will be a minus root b. Got it? Similarly, if I talk about third part, non-real, right? This is a very important thing, non-real. So if I talk about non-real roots, that means d is always less than 0. So if alpha is a plus iota b, automatically the beta, they will be conjugate pairs, right? A minus iota b. This is always there. Is this clear to you? Fine. So you can see here we have d greater than 0, b square minus 4ac, perfect square, roots are rational, b square minus 4c is not a perfect square, roots are irrational, and this is non-real, d is less than 0. This is always like that. Got it? So this is a very, very important thing. Right? So hopefully this is clear to you. Let me know if it is okay. Everyone, just have a look at this. Come on, fast. Yeah, is this okay, beta? Everyone? Done? Yeah, everyone, is this okay? All of you? Chalo, great, great, very nice. Okay, fine. Now just have a note, I just give you a note on that. Suppose we have been given ax square plus bx plus c. This is a very shortcut thing, but many times this concept is used, okay? Here what happens? Ax square plus bx plus c is given to you equal to 0. Alpha, beta are the roots of this equation, yes. So if a plus b plus c is equal to 0, the roots are, always remember, 1 and c by a. 1 and c by a, right? Suppose you have been given an equation a minus b into x square plus b minus c into x plus c minus a, suppose that is equal to 0, right? And we have to solve this equation. So if you can just add all the terms, the coefficients and the constant, that is coming out to be a minus b plus b minus c plus c minus a is equal to 0, right? So you can see the initial condition is satisfied, isn't it? And we have been given the roots will be automatically 1 and c minus a upon a minus b beta. Got it? Right? Okay. Now, if the roots are equal, say roots are equal, suppose this is equal to this. So, what we can say? We can say a minus b is equal to c minus a. Right, this is twice a is equal to b plus c, isn't it? Twice a is equal to b plus c. That means b, a, c are in AP, isn't it? So this is the condition what we use. I hope this is clear to you, right? So we have many problems which are based on the nature of roots, where the roots are, the perfect square, right, and irrational roots. So you'll get many problems, and you have to use those properly. That is more important. Got it? Okay. Now I will go to the next part. That is just have a look at this part. This is a chart what I have drawn. You can just have a look at this part. We observe the following results. So you can just look at this. You can just prepare the chart like this, right? I mean, that will be very nice if you can do it, right? So you can expect one question from this concept, this chart, right? You see, D is equal to 0, roots are equal. D is not equal to 0, roots are unequal, right? A, B, C belongs to R, D greater than 0, roots are real. A comma B comma C belongs to R, D is less than 0, roots are imaginary. We have this. A, B, C belongs to Q, D is a perfect square, roots are rational, isn't it? A, B, C belongs to R, D is not a perfect square, roots are irrational. So if alpha is P plus root Q, then beta is P minus root Q you have. Got it? Fine, you can see the chart. It's a very interesting chart. You can just always remember this chart. It's a very interesting one. See. Got it? Yes. All of you. Is this fine? Great. Okay. Now let me go to few problems now, right, based on the concepts of roots. So you can see the first question. So I want everyone to try this one. Okay, it's a very simple one. Just think about this question. This is the basic questions, but yes, as in JEE Mains, so just I have taken this question. Just do it. Come on, fast. You have been given determine the values of m for which the equation 5x square minus 4x plus 2 plus 4m into 4x square minus 2x minus 1 is equal to 0 will have equal roots, right, and product of the roots as 2. Got it? So this is the question. Come on. Let me see who can solve it. Fast. Yes. Sanjay, Chetna, come on. Pratik, Disha, Yuva. Yes, beta. I'm giving you 2 minutes, right? Just try. Fast. You have been given 5x square minus 4x plus 2 plus m into 4x square minus 2x minus 1 is equal to 0 will have equal roots or product of the roots as 2, right? So that means first of all we need to convert it into a standard form. You have to convert it into a standard form. That is more important, right? So how can you do? We can take all the x squared together, right? Yes, this is the first step you can do. That is 5 plus 4m into x square, right? This is what we have. And also we can write it as minus 2m minus 4 into x plus 2 minus m is equal to 0. This is what we have. What I have taken? I have taken 5 and 4 together. 5 plus 4m square minus 2m minus 4 right? From here we have taken 2 is left out, so 2 minus m is equal to 0. I think this is the first step you people can try, isn't it? M is equal to 1 we get, is it? So just have a look at this part. Come on, students. Sanjay has given yes. Okay. Now, how to go about this part? So, equal roots, d is equal to 0, yes, right beta? So, this is A, and this is B, and this is C, right? Okay. So, what we have been given minus 2m minus 4 square minus 4 times 5 plus 4m into twice minus m is equal to 0, isn't it? This is what we have. So, you can do it, the calculation, minus 2. So, that can be cancelled, minus 4 can be taken outside. So, we are left out with only m plus 2 whole square minus of 5 plus, because 4 is not equal to 0, right? So, we have 5 plus 4m, 2 minus m, that is equal to 0, isn't it? This is what we have. Got it? Now, this is m square plus 4m. Yes, this is coming out to be 4 minus of 10 minus 5m plus 8m minus 4m square. That is equal to 0, right? I hope this is okay to everyone, isn't it? So, 5m square is there. This is 3m. So, this is coming out to be m, right? Is it? And we are getting minus 6, which is equal to 0, right? Or this can be written as 5m square plus 6m minus 5m minus 6 is equal to 0, is it? Or we can write it as m, this is 5m plus 6 minus 1, this is 5m plus 6, which is equal to 0, right? This is what we have. So, that means we have m is equal to 1, fine, m is equal to minus 6 by 5 also. This is the first one, is this. Got it? Then you can see the second part. The product is 2. So, we have 2 minus m, c by a, right? 5 plus 4m is equal to how much? 2. So, we can write it as, we can just do the calculation now. This part. This is 2 minus m is equal to 2 into 5 plus 4m. 2 minus m is equal to 10 plus 8m, right? Which is 9m is equal to minus 8. M is equal to, right? So, you can say, have a look at this part, isn't it? Minus 8 by 9. Got it? Hopefully, this is okay to everyone. Yes, let me know if it is fine. Yes, beta. Okay, done? Everyone? Great, great. Very good. Prinsika, very nice, beta. Yes. Chetna, Yuva, very nice. Disha is really nice. So, you can see the second part also, minus 1 and 655. Great, great, beta. Very nice, very nice. Yes. Got it? Got the second one also? Just have a look at it, beta. Hopefully, this is clear. Let me know if it is okay. Chalo, done. Great. So you can see the second part also the same thing what I have written here, just I have multiplied, nothing else. Beta is actually, this is nothing but alpha into beta is C by A. So C is this and A is this. So I have divided, right? I have divided and I have cross multiplied. So 2 into 5, 10, 8m. I have taken 9m on this side, 9m, 10 on this side. So 2 minus 10 is minus 8, m is minus 8 by 9 we have, right? Okay. Now you see, we have one more. It's a very interesting one. This is again a very important question, and such type of questions are generally seen in JEE Mains. Again based on the roots, properties of roots. So if you see here, you have been given alpha and beta be the roots of the equation x square minus 6x minus 2. If an is alpha n minus beta n for n greater than or equal to 1, then the value of 8n minus 2a8 upon 2a9 is equal to what? Whether 6 minus 6, 3 or minus 3. This is what we have. Can you just have a look at this? Come on, fast. Yes. Just try. I'm giving you 2 minutes. I'm giving you 2 minutes. Come on. Do it. Right? Chalo. So, how to go about this problem, right? So, if you see here, you have been given alpha plus beta to be 6, alpha into beta to be minus 2, right? And we have to find this value. So, an is given as alpha n minus beta n. So, that means a10 can be written as alpha 10 minus beta 10, and a8 can be written as a8 can be written as alpha raised to the power 8 minus beta raised to the power 8. Got it? So what we have, we can just substitute the values. What we can write alpha raised to the power 10 minus, right, beta raised to the power 10. We substitute in place of alpha, a10, right, minus of 2. This is a raised to the power 8 minus b raised to the power 8. Got it? Divided by 2a9, 2, this is alpha 9 minus beta 9, right? This is what we have. So, students, this is a very important thing, minus 2, because we have to take the factors now. Minus 2 is going to play a very vital role because this is nothing but alpha beta. Minus 2 is alpha into beta. So, you have to always remember such type of questions were asked, and regularly in JEE Mains. So, you need to be very careful that how the placement can be done, right? Again, I am telling you, just remember my word, placement of roots alpha and beta, any relation in a particular expression is very, very important. You have lot many problems based on this. You got my point? Yes, you should. So, alpha 10 minus beta raised to the power 10, and this is nothing but what? We have alpha into beta. This is alpha 8, sorry, this is alpha 8 and this is beta 8, right? I have written, this is beta 8, okay? And I have this divided by twice of alpha 9 minus beta 9, got it? Okay, so this is what we have, fine. Now, alpha 10 minus beta 10. So, what we can take, we can just, take this alpha 10 plus alpha raised to the power 9 beta, that is alpha 10 plus alpha raised to the power 9 beta minus beta 10 minus beta raised to the power 9 into alpha, right? This is what you can take, isn't it? Whole divided by, we can write it as twice of alpha raised to the power 9 beta raised to the power 9, correct? This is what we have, fine. See, it's a very interesting sum, right students? So what we can do, we can take alpha raised to the power 9 common and we can write it as alpha plus beta. Similarly, we can take beta raised to the power 9 common. This is nothing but alpha plus beta. And this is okay, this is divided by, we have twice of alpha 9 minus beta 9, right? This is what we have. So alpha 9 minus beta 9 will be cancelled because alpha plus beta will be taken common. So alpha plus beta is what? We have been given minus 6, right? Minus 6 has been given to us, is it? 6 is given to us, right? So I can write it as alpha plus beta divided by 2. So which is coming out to be how much? This is coming out to be 3 then, right? Alpha plus beta is 6 upon 2. Got my point? Just have a look at this sum and let me know if there is any problem, if the steps are clear to you. Fine. Very interesting sum, students, and a very commonly asked question. Such type of questions are very, you can view this almost lot many problems are there in last few years, right? Same type, the placement of the alpha plus beta and alpha into beta, right? Just have a look at this. Come on. Yes, Ravi, yes. Yes, Yuva. I hope this is clear to everyone. All of you. So can you explain the second part? Second part of what, beta? This one, second step. See, what I have done, I have just substitute the step number 1, right? This step number 2, step number 3, step number 4 and step number 5, right? What I have done, I have just substitute minus 2 here because alpha into beta is minus 2, na beta? Alpha into 2 is minus 2, right? So alpha into 2 minus 2 means if we write plus alpha, plus, because already minus 2 is there. So in place of minus 2, we can write plus alpha beta, na? You got my point? Then we can take the common. Got it? Is this clear, Shubham? Yes, beta. Second step is okay. Right? Then we just, once we have taken this, then we can just substitute, we can multiply. Then what we have taken, all the alpha 9, the higher power of alpha we have taken together. Then beta 10, beta 9 we have taken together. Then we have taken alpha raised to the power 9 common and beta raised to the power 9 common. And we can just plot the values, we get the answer is 3. Got it? Okay. So this is one very, very important thing what we have discussed. Hopefully this is clear, right? Shubham, I hope this is okay, beta. Yes, let me know if it is okay. So you can see here, I can see the messages which are coming here. So everyone has given a positive vibe. So, that's really nice. So Shubham is there. Shubham, I hope this is okay, beta. This is the second part you are talking. Iski baat kar rahe the aap? Second part you are talking. Or the previous question. Okay. Last step. Now it's okay, Sanjay? Yes, that's going to be a very difficult task. Yes, of course. Last step is, what I have done, Vignesh, I have taken this alpha plus beta and alpha plus beta common, right? And this is alpha raised to the power 9, beta raised to the power 9. Got it? I have taken alpha plus beta common and this is alpha raised to the power 9 beta, and also in the denominator we have alpha 9 beta 9. Can you see that? So that's why this is cancelled and this is cancelled. You got it? I hope this is okay. Fine. Chal. Right, Yuva? Ravi? Ravi, let me again explain it, because just today many students are joining, and maybe sometimes it may happen that it's the first class, so coming into the class is going to be a problem, because the team is working, the back-end team is also working to get into the class, you people, right? So it may happen. So we may repeat some questions because of many the intervention in terms of coming to the class, right? So one question again, that can you explain it? Ravi is asking, can you explain it, sir? X square minus 6x minus 2 is there, alpha and beta are the roots of the equation, right, Ravi? And alpha plus beta is given as 6 and alpha into beta is given as minus 2, right? An is alpha n minus beta n. So I can write it as alpha 10 minus beta 10. This is minus 2 alpha 8 minus beta 8 divided by 2 into alpha 9 minus beta 9, right? I have just substituted. In place of n, I have written 10. Here I have written 10, right? Similarly for 8, I have written 8, 8. I substituted, right, Ravi? Then what I have done, I have taken minus 2. In place of minus 2, I have written plus alpha beta, because alpha into beta is minus 2. I have written plus alpha beta. Then I simplify it. Okay, simplify it. Once we simplify it, we get alpha plus beta, all the terms are cancelled and we get alpha plus beta by 2. Is this clear? Right? Chalo, got it? Ravi, is this fine now? Right, you can just see the question. It's a very simple one, beta, not a problem at all. Now you see, this is a very common concept we have. Now if you see here, we have a very important fundamental, the location of roots, right? Location of roots. So we'll discuss one by one the location of roots, right? So before going to the location of roots, let's first of all understand the sign of quadratic polynomial. Okay, let's have a look at this part, then we'll discuss one by one. There are 6 rules which are very, very important rules we have. Correct? Okay. Now you see, when you say sign of quadratic polynomial, sign of quadratic polynomial, right? Or quadratic functions, we can say, isn't it? This is what we have. Got it? Sign of quadratic polynomial or quadratic function we are talking about, isn't it? So px is equal to ax square plus bx plus c. So this is nothing but, this represents a parabola. We know that, isn't it? This is a parabola actually. Why it is a parabola? Because whatever substitute, this is y actually, right? This is y. So whatever values we take, x is equal to, we get some values for y also. If you substitute x, then we get some y. So when you plot those x and y, we get a parabola like this, or maybe like this, isn't it? This is what we have. So you see here, students, what we have. You can just have a look at this part, very interesting one. Let me take the cases now. This is what we have, right? This is 3 different cases we'll take, because this concept is very important for us, right? It's very, very important for us. Correct? So we have 4 cases. You can see here, this is the origin we are talking about, right? So when you say a parabola, what does it mean? What does it mean? It means we are talking about this one. We are talking about this one. We are talking about this thing. Or maybe we are talking about, this part. Or maybe we are talking about this one. Or maybe we are talking about this. 4 cases. Got it? Now, see, what we have? We have been given this 0, origin and loss. So always remember, whenever a parabola open upwards, a is always greater than 0. Doesn't touches it, the x-axis, d is less than 0. Right? A is greater than 0, touches it, equal roots, d equal to 0. Open upwards, 2 distinct roots, d is greater than 0. A less than 0, d less than 0, right? A less than 0, D is equal to 0. Got it? A less than 0, D is greater than 0. Two distinct roots we have. Can you see that? Right? So these are the four conditions, always remember. This is very, very important. Right? So whenever you have been given a parabola or a quadratic polynomial, now this is a general perception we have, right? How you draw it, because the knowledge of 10th comes into picture, isn't it? Or maybe in physics, or maybe in you have done it in coordinate geometry also, right? Now the most important thing which I was going to discuss is, like, let's have a look at this part. Very interesting one. Okay. See, if I have been given something like this, so what is sine of a quadratic polynomial? So what I am saying is, I am talking about a parabola, and if I am talking about sine of a quadratic polynomial, what does it mean? I am talking about the value of y, the sine of y actually. Right. So this is this is a basic thing I am explaining you. I will take 2-3 minutes for the same. Then we will go to the location of roots, which are very, very important for us for the examination point of view. Now, if you see here, students, we have been given a point here, and this is a point. We have this is a point. This is a point. We have this as a point, right? So for every x, right, we get every y, right, isn't it? Every y positive, because this is lying above the x-axis. Can you see that? This is what we have, right? Suppose you have been given this. So from here to here, suppose we have been given alpha and beta, these two roots. So let's understand. From here to here, every y, the value of the polynomial, the quadratic polynomial, is always negative, right? Okay. Now, when you talk about less than alpha, this part, so the graph is moving above now, so this is going to be very positive, right? So y is always greater than 0. You got it? Similarly, if I talk about this part, greater than beta, we have y always greater than 0, students. Just have a look at it and let me know if it is okay. Is the concept clear? Just have a look at it. Very, very important part, beta, right? If you know this thing, then many things are going to be cleared. Yes. Is this okay? So the most important part is that you can view this session again, right? Sometimes it may happen that you may not be able to ask some questions. So you can just have a look at the session again, because this is recorded, so it is always available to you. You can just go through it, right? So that is one point, very important point you have. Got it? So I can see everyone has given a positive. So is this a first? Yes, Ravi, you have started today only, beta. We have started today, right? So that is always the value. See, this is when it cuts here na, y is always 0 na beta. At alpha and beta is always, Sanjay, this will be always 0, right? The value of y will be always 0 in the x-axis na, right? Because if it touches na, at this point this will be always 0, right? Okay? Right, Sanjay? Okay. Now, let us go to the next part, the location of roots now, right. So, the location of roots is basically a concept where we are placing constants between the roots, away from the roots, or maybe on left hand side of the roots, or maybe on the right hand side of the roots. Got it? Maybe on the left hand side of the roots, or maybe on the right hand side of the roots, right? So that means if you have been given fx is equal to ax square plus bx plus c, where a comma b comma c belongs to R, is not equal to 0, alpha beta are the distinct root of fx, right? So what we have, suppose we have k, right? So k lies between the roots of fx is equal to 0, right? So k lies here, and this is alpha and beta, say. You got it? Right? So you can see here d is always greater than 0, beta. D is always greater than 0, right? Two distinct roots, a into f of k. Now you see, if this k is here, as I told you in the previous discussion, because k is x, so the graph is going below the x-axis. So what is f of k, beta? What is f of k? F of k is, if it is below the x-axis, f of k is less than 0 or greater than 0, beta? F of k is less than 0 or greater than 0? Because this is x is equal to k. Can you tell me? It is less than 0 or greater than 0? Come on, fast. Because this is going below the x-axis. For this k, corresponding y will be what? Below the x-axis. This will be less than 0, right? Okay, so this is going to be less than 0. Now a is greater than 0, yes. So if we multiply, then we get f of k is a into f of k is less than. So these are the two conditions we have for this case also and this case also. And this is the vertex, my dear students. Always remember, the vertex is very important. Sometimes you may be given a very simple question. So what is the vertex of the given, quadratic polynomial? The expression will be given. We can just directly substitute this value. Minus b upon 2a, we can just collect a and b from the given equation. We can substitute and we get the answer. Hopefully this is okay, right? So this is the condition, my dear students. So we can just have a look at this part. So whenever a problem is given, find the value of a, any variable a, right? Or maybe k, whatever. I mean, k is obviously k is equal to something, value will be there. K is not k. In the question it will be given as 3, 4, 5, whatever, isn't it? They will be asking in such a way, they will be saying that 3 lies between alpha and beta, find the parameter a given in that particular equation, say, right? So we'll do one problem based on that, right? So this is what we have, fine. Similarly, if we go into that part, if the roots of the quadratic equation fx is equal to 0 are greater than k means k will be here, then alpha beta here, right? So alpha beta is always greater than k. Alpha beta is always greater than k. So that means if this is there, or maybe here also the same thing, if it is opening downwards, both the cases, in the previous one also, this case and this case, the condition will be the same, right? Here the condition will be something like this. We have k, we have d greater than equal to 0, yes, this is one condition. A into f of k is greater than 0, this is also fine. Now this condition is nothing but between alpha and beta, alpha plus beta divided by 2 we can write. Got it? This is what we can write. So alpha plus beta, so k is always less than alpha plus beta by 2. What is alpha plus beta? That is minus b upon 2 into a, right? This is what we have. So these are the three conditions we can write. Got it? This is what we have. Fine. So when you just see the recording, or maybe you can view it again, you can stop the screen, stop it, and you can just write it down, right? So that will be very nice. Okay, just to remember these conditions. Now, if I talk about the third case, if the roots are less than a number k, that means alpha and beta are here and k is here. So that means these are the three conditions we have. Again, same case, this case and this case are same. Basically, this is opening downwards and this is opening upward, right? So that means D is greater than equal to 0. A into f of k is greater than 0. K is greater than minus b by 2a we have. You got my point, beta? Right? Okay, this is the condition we have. Got it? So you can see here where I have placed k, whether greater than alpha beta, less than alpha beta, or in between them. Right? So you can see three conditions written here. Fine? Yes, absolutely beta. Yes, less than. Right? So similarly, if we say exactly one root lies between real numbers k1 and k2 where k1 is less than k2. So what we have? We have been given alpha and beta. This is k1. This is k2, right? So k1 and k2, there are two numbers, real numbers. Suppose there are two cases we have. So here we have to use two things only. That is D is greater than 0, f of k1 is into f of k2 is less than 0. See, for k1, the corresponding y will be what? As I told you, f of k1 is less than 0. For here, this k2, this k2, this is greater than 0, sorry, this is greater than 0, and f of k2 is what? This is less than 0, fine. So f of k1 is greater than 0, f of k2 is less than 0. If you multiply positive into negative, it becomes less than 0. So this is one condition. When this type of things happens, two numbers have been given. It's a very, very important topic you have. Similarly, if we have both the roots of fx is equal to 0 are confined between the numbers k1 and k2, where k1 is less than k2, you have these conditions. We have k1, we have k2, right? Then we have alpha beta. So here what happens? Because f of k1 is greater than 0, then we have f of k2 is greater than 0, right? Here the same thing, f of k1 is less than 0, right? A of, got it? That is f of k2 is less than 0. So since a less than 0, here a is greater than 0, so their product will be always greater than 0. This is the condition we have. Okay, just have a look at this. If you want, I can explain you again. Done? Yes, beta. Let me know if it is okay, everyone. So basically, you have to just, I have taken one by one, right? Maybe you might have not got time to write it down, not a problem. You can just take a snap, or maybe you can just, after the class, you can just have a recap, review the session, and you can just write the points, not a problem. Fine. So it's not about going fast or easy. If things are clear, the notes are always there with you, at your disposal, right? Right, beta? Chalo, great, great. Similarly, we have for sixth also. K1 and K2 is there, alpha and beta is there, alpha and beta is there, K1 and K2 is there, but K1 and K2 lies between alpha and beta. That is the most important thing. You got it? Now students, let's have a look at this part, see how it works. K1 again it is going downwards, right? K2 again going downwards, isn't it? So the corresponding K1 will be, y will be what? It is less than 0, isn't it? Here also f of K2 is less than 0. So D is greater than 0, A of f of K1 is less than 0, A of f of K2 is less than 0. Similarly, here also if it is K1, it is K2, this is f of K1, this is f of K2, right? This is what we have. So this is greater than 0, this is also greater than 0. So you can just see, because this is less than 0, A is greater than 0, yes. So multiplication will be always less than 0, this is always less than 0. So you can just have a look at this, right? It's very important, very, very important. Okay, okay. Now, if I take some problems now, let's see if we can have a problem from, yes, we have this problem, yes, this one. The values of A for which the roots of the equation x square minus 6ax plus 2 minus 2a plus 9a square is equal to 0 exceeds 3. So roots exceeds 3. So roots exceeds 3 means we are talking about something like this, right? Alpha and beta, is it? These are the things we have. Exceeds 3, isn't it? Got it? So what we have, yes, D is greater than 0, 1. Then we have alpha plus beta here, alpha plus beta by 2, alpha plus beta by 2 is greater than 3, you know, this is one part we have, and we have A into f of k, A into f of k is greater than 0, right? This is what we have. Can you see that? Isn't it? Got it? So these are the conditions we have. Right, students? So how the questions are asked? The main focus is in that. Calculations you can do. The question was, like it has been asked that this is a polynomial we have, and we have placed that polynomial in this way because the coefficient is 1, the coefficient of x square is 1, it always open upwards. So it's something like that. So alpha beta is always exceeds 3, they always, this is always greater than 3, right? Okay, so these are the 3 conditions we can have. What do you say? It is okay, everyone? Yeah. Is this fine, beta? Till now it is okay, everyone? Just so we can see here A less than 1, A greater than 1. So what we can do, we can use the conditions. So I would just ask you, I just want you people to do it, right? D is greater than 0. So if D is greater than 0, what does it mean, beta? D is greater than 0, right? So that means we are talking about what? Right? We have 36a square, b square minus 4ac minus 4 times 2 minus 2a plus 9a square, right? Which is greater than 0, isn't it? This is what we have. Can you see that? B square minus 4ac is greater than 0. 36a square plus 4 into 1 into 2 minus 2a plus 9a square. Okay. So we have 36a square minus 8 plus 8a minus 36a square is greater than 0. So this is cancelled. So it goes this side. So A is greater than 1. Can you see that? This is one part we have, right? Alpha plus beta by 2 is greater than 3. Alpha plus B is greater than 3. So alpha plus beta is minus B by 2A, right? So minus B by 2A means we are talking about minus of 6A divided by 2, which is greater than 3. So minus minus plus, na? So this becomes plus, right? Isn't it? Already we have minus sign, so minus of minus. So this is coming out to be A greater than 1. This is one condition we have. Got it? A is 1, f of 3 is greater than 0. So if A is 1, that is f of k is greater than 0 means we are talking about k to be 3. So f of 3 is equal to, we have 3 square minus 6a into 3 plus 2 minus 2a plus 9a square is greater than 0. This is one part. Got it? So what we have? We have 9 minus 20a, right? Yes, plus 9a square is greater than 0, or 9a square minus 20a plus 9 is greater than 0, is it? Or something here, just have a look at this part. 20a we have, something is missed out. Yes, this is 18a, 20a, right? So we have what? Yes, so we can write it as 11a minus 9a plus 9 is greater than 0. Got it? This is what we have. Or we can write it as a, this is 9a minus 11 minus 1, this is a, right? So just have a look at this calculation part. Yes. Isn't it? 99, oh, sorry, 9. So we can just check it here, beta. Just have a look at this part. Yes. So what we have? We have 3 square, which is 9, right? 3 square is 9. See the substitution here. Yes. A is 3, 9, 18 plus 2a minus 9a square. Is it? So we can just have a look at this part. Come on. Yes. So what we can do, we can just have a look at this. So what we have been given 9a square, right? And this is what? This is coming out to be 20a and this is 11, isn't it? Because 9 plus 2 is 11, which is greater than 0. So what we can do, we can take it as 9a square minus 9a minus 11a plus 11 is greater than 0, right? This is what we have. And we can just substitute 9a, this is a minus 1 student, this is minus 11, this is a minus 1, which is greater than 0. So what we have been given a minus 1, this is 9a minus 11, which is greater than 0, right? So we have a greater than 11 upon 9 and a less than 1. So you can see here, there are 3 conditions we have. So when you join, when you see the common range, we'll get this part. So have a look at the calculation part. Let me see if the things are okay. Fine. Just have a look at it. Come on. Right? Yes. Okay. Is this okay now, everyone? Right, beta? Is this okay, all of you? Okay, right? Just have a look at it, come on. So, a is greater than 1, so the final answer will be a greater than 11 upon 9, right? Okay. Now, let me go to the next part. The next part is the common roots, the concept of common roots will come, right? So, there is a problem on common roots, very interesting one. Let us have a look at this part. Before going to the problem, let us have a look at this concept now. There are two equations, the common roots, and it is a very common part we have, right? Common, we generally get a question from this part also. We had around 3-4 questions in last 10 years. Common roots. Suppose you have been given a(n)x square plus b1x plus c1 is equal to 0, right? This is what we have. We can write it as a2x square plus b2x plus c2 is equal to 0, right? So, there are two cases. Either there will be both the roots common, right? Both roots common, or we have one root common. We have both the roots common or one root common. Now, if we have both the roots common, students, if you have both the roots common, right? So, that means we are talking about, say, suppose this is equation number 1 and this is equation number 2, right? So, what do we have? We have 1, got it? And that is coming out to be, say, alpha and beta. Say, both the roots are common. From here also we have alpha beta, we have here also alpha beta. Roots are common. So, whenever two roots are common, students, right? So, always remember a1 by a2 is always equal to b1 by b2 is equal to c1 by c2. This is a very, very important condition we have, right? When both the roots are common. How is it so? Alpha plus beta is minus b1 by a1, right? Alpha into beta is c1 by a1. Again, alpha plus beta is equal to minus b2 by a2. Again, alpha into beta is equal to how much? c2 by a2. So, when you equate all these things, right, this is what we have, alpha plus beta, alpha into beta, alpha plus, so we equate it, we get this part, all right. When you have one root common, so we have a1 alpha square, b1 alpha plus c1 is equal to 0, right. We have a2 alpha square plus b2 alpha plus c2 is equal to 0. Can you see that? Right. So, here the specific form is like you can remember a formula, but if there is no formula, if you do not want to remember that formula, right, what we can do? We can use the cross multiplication method here. You can write it as b1, b2, c1, c2, right, which is equal to minus alpha or plus alpha rather, c1, c1, c2, a1, a2 this way, or 1 divided by a1, a2, we have b1, this is b2 we have, got it? So, this is coming out to alpha square, this is b1, c2 minus b2, c1, this is alpha, c1, a2 minus a1, c2, this is 1 upon a1, b2 minus b1, a2, right. So, 1 alpha square can be taken here. So, this is nothing but alpha square will be what? b1 c2 minus b2 c1 divided by c1 a1 b2 minus b1 a2, right. Then we have alpha is equal to c1 a2 minus a1 c2 whole divided by a1 b2 minus b1 a2 we have, got it. So, we can square it up. So, if we can square it, we get c1 a2 minus a1 c2 square whole divided by we have a1 b2 minus b1 a2 square. So we can equate these two, and that is coming out to be the condition we have, right? Just write it down. Right, beta? Can see the conditions here. So for both the roots common, this is the condition, and for one root common, we have this is equal to this part, right? So this is how we learn it. Both are alpha square, so this is the way how we learn it. I mean, don't have to remember this, we can just substitute and we can get the values. Got it? Yes, beta. Let me know if it is okay, everyone. Is the pace okay, beta? Can I have a is the speed okay? Not a problem from your side? I can just need your feedback on that. Because we have very less time, so you have to be very well prepared for the same, right? So I'll go a bit, wherever needed, we'll need a description, we'll do the description part, we'll do analyze, we'll do the theory part. If not needed, if shortcut is needed, I will use the shortcut, right? So that is what I'm going to do, because we have very less time left out, right? So, you need to be very focused on that, okay? Chalo, great. Okay. Now let me take one problem. This one. This is the question we had. How will you do this one? If the equations x square plus 2x plus 3 is equal to 0 and ax square plus bx plus c is equal to 0, where a, b, c belongs to R, have a common root, then a is to b is to c is what? 1 is to 2 is to 3, 3 is to 2 is to 1, or 1 is to 3 is to 2, or 3 is to 1 is to 2. So you can have a look at this part. I think it's a not very tough, but yes. Yes, okay. So you see how this question is going to be very interesting one. Here x square plus 2x plus 3 is equal to 0 is given, right? Now here a, b, c, so there is a huge difference. I mean, here a, b, c variable is given, and here we have given x square plus 2x plus 3. Okay. Now, if I have d is 4 minus 4 into 3, so this is coming out to be the negative part, right? Minus 8, which is less than 0. That means non-real roots, imaginary roots. So if one root is imaginary, automatic we know the other root also. Because let us say this root has a plus iota b. One root is a plus iota b, right? So automatically the other will be a minus iota b. So basically if we see, both the roots are common. One root is confirmed because a plus iota b, because this is less than 0. So both the roots are common. Then because this root is also known to us because they always occurs as a conjugate pair, right? So that means if we have a plus iota b of this, so a minus iota b will be the automatic the other choice, automatically will be the other choice, right? So that means we have both the roots common. So what we can do, we can take this condition, a1 by a2 is equal to b1 by b2 is equal to c1 by c2, right? This is what we have. So that means we have 1 upon a or 2 upon b is equal to 3 upon c, or we can write it as a is to b is to c is equal to 1 is to 2 is to 3, right? This is what we have. So first one will be the correct answer, right? Yes, very nice, beta, very good. Yes, Yuva, really nice, good, right? Prinsika, very good. Yes, Ravi, very nice, very good, beta. Hopefully this is clear to everyone. Yes, let me know, bache, if this is okay. Great, great. All of you? Yes, beta. I want you to practice a lot, right? Because practicing will give you the things much more clear. So last 10 years, last 12 years, 15 years questions you can just solve. You'll have lot many concepts. I mean, concepts are obviously we have there, and if you use it, you'll see that utilization of the concept is much more important. Rather limited number of concepts are there, but again, using it in different questions, different types of questions is a challenge for us. So it's basically practice and types of questions, as I told you in the starting of the class, beginning of the class, that you have to focus on, right? Okay. Now you see, let me take one more problem, right? And I can see here, it's a very interesting one. Let's have a look at this question now. Seems to be a very easy one, right? Is it? It's a power type question, yeah? The power is there, the exponent is there. Yes. So there are few confusions. Yes, maybe one value you may get, but there may be some different cases in this particular expression, in this equation. And that is the irony of, that is the importance of this question actually. Seems to be very easy. This is a JEE Mains question, right? I think 2018 it has been asked, or 2019 I suppose. The irony is that we know that anything to the power 0 is 1. That is one question, that is one part, that's really that we know, right? We have been given a raised to the power b, say a raised to the power b is equal to 1. So that is what we know is b is equal to 0, right? B is equal to 0. That means we have x square plus 4x minus 60, this is equal to 0. Isn't it? This is one condition. So case 1 we can take. So if we take this equal to 0, anything to the power 0 is 1. So we can just factorize this. How much we can take? Yes, 10x minus 6x minus 60 is equal to 0, right? So x plus 10 minus 6, x plus 10, which is equal to 0. So x is equal to minus 10 and 6. Case 2. Now one more thing is, now 1 to the power, this what can be the other case? Right, what can be the other case we have? Anything else you can suggest something more if you have any suggestion for. Yes, let me know beta. If you have any suggestions you can give me. Yes. Yes, we have the third option. Okay. Option D might be. Okay, Ravi. Let's see. B option, Pratik says, Sanjay says option A. Anyone else beta? Yes. Great. Chetna is also coming out with the question. That's really nice. Yes, absolutely beta. Now one more thing is, like, if we can take 1 raised to the power anything, so case 2 can be x square minus 5x plus 5 is equal to 1. Is it possible? Yes, we can. So x square minus 5x plus 4 is equal to 0, or we can write it as x is equal to 1 and 4, right? This is 1. Got it? And we can have one more case. Case number 3. This is the most important thing. Maybe the confusion part is there. What we can take? We can take x square minus 5x plus 5 is equal to minus 1, provided x square plus 4x minus 60 is even. You know, this is the condition we have. Very, very important condition. Got it? This is the even part we have, right? Or we can write it as x square minus 5x plus 6 is equal to 0, where x is equal to 2 and 3. So we can substitute the values, that is 2 square plus 8 minus 60, which is even, right? It can be written even, is it? Isn't it? What about 3? 3 square 8, that is 5 into 3, 15, right? And this is coming out to how much? Just see if the things are okay. Isn't it? So if we take 15, this is 60, this is coming out to be odd, right? Is it? Just have a look at this. Is it coming to be odd? Right? We can just substitute the values. X square plus 4x minus 60. So we have to check whether it is even or odd. So we have taken this. So this is coming out to be 4 into 3, 12. Sorry. This is 12, right? So this is coming out to be odd. Fine. So this is odd, this is even. That means 2 is satisfied. So we can take x is equal to 2 here. 3 is not. So what we can do, we can add minus 10 plus 6 is minus 4, 5 plus 2. That is coming out to be 3. So the final answer will be 3, right? Yes, everyone. Is this clear? D is the correct answer bit. Got it? Okay, this is the JEE Main 2015 question, yes. Now Ravi, is this clear everyone? Is this great beta? Done? Shubham, is this okay bache? Chalo, right? Okay. So we have completed the concepts of quadratic equations, right? and from tomorrow we'll be having the class on complex number, right? So just revise the basics of complex number, come prepared with complex number basics, right? Read the NCERT or read some books, right? Whatever the study material you have, come, and then we'll discuss lots of problems beta. Hopefully quadratic equation part, the important concepts which are very generally asked in the examination, things we have discussed today, and things are clear to you. Thank you then. God bless you beta. Take care. Bye.